Alright, so this is 3.3 for trigonometry, math 10C. We're not going to learn too much new today. We're just going to look at different types of word problems and different ways of challenging them. So this very first word problem you see, they ask you to find the value of theta to the nearest whole degree. They've labeled theta here right for you. The problem we have with this question is you'll notice that we don't have a 90-degree triangle, and Sohcahtoa can only work with a 90-degree triangle. So what we need to do is we need to find a way to create a 90-degree triangle in this problem, and we do that by cutting it in half. When we cut it in half, we create a 90-degree triangle on either side. You get to choose which half of the triangle you want to work on. I'm going to work on the right side of the triangle because they've told us the 3.7 over here, even though we've assumed this is an isosceles, and we could have assumed the other side was also 3.7. The thing that changes when you cut it in half is theta is now cut in half. So that value right there, we're going to have to double it when we find it. And this 2.2 is also cut in half. So that side length is 1.1. Now let's try solving for theta. So your first step is labeling the triangle, writing out Sohcahtoa, checking off your SC and T, and then checking off your O's and H's. You'll find one of them has 3 checks. So we have to use the sine ratio. That's what this thing stands for. So sine of theta equals opposite and 3.7. The reason why we checked off O and H is because we had our opposite and our hypotenuse sides. Now to solve this thing for theta, we need to do second sine. So in your calculator, you had to hit the second button and then sine. And what that does is it creates this different looking sign where there's this -1 here. If you put that in your calculator, you'll actually get your answer for this question. So second sine 1.1 divided by 3.7 should give you 17.295. Remember, that's only half of theta, so we have to times that by 2. And you get 17.295 times 2 equals 35 degrees. Okay, question 2. A 7-meter tall flagpole casts a 13.2-meter shadow. So we're going to want to label both those. 7 meters is our beautiful little flagpole. When you're measuring a shadow, you're measuring along the ground. Because that's where the shadow is, it's on the ground, so 13.2 there. Determine the angle from the edge of the shadow to the top of the pole. So right there, that's the edge of the shadow to the top of the pole. We're going to call that theta. So we want to solve for theta. Again, you're going to use Sohcahtoa. You already know 2 side lengths, so you just have to label your sides. Write out Sohcahtoa. Check off your things that you know, which is our opposite and our adjacent side, and you'll find that you have TOA is what you need to use. So tan theta equals opposite 7 divided by adjacent, 13.2. Remember, if you're trying to find an angle, you have to use second tan. So it's tan, and when you hit second tan on your calculator, that little -1 exponent comes on it. And now you can put the fraction where the angle used to be. You punch that in your calculator and you get the answer to your question. So in this case, we need 28 degrees is theta. Alright, this is the only part of the lesson that's really new. So what we want to look at is 2 terms. We want to look at angle of elevation, also called angle of inclination, and angle of depression. So these are 2 different types of things we work with. They're pretty similar. When we think of the word elevate, or incline, we think that it must go up. And we think of the word depress, we think it must mean down. So when you hear angle of elevation, what they're referring to is an angle that's going upwards. Over here in the little diagram, you can see that they have an angle that goes upwards from a horizontal line to create an angle. And in the other question, they have an angle that comes downwards off of a horizontal to create an angle of depression. Now, it's not a coincidence that these are always coming off of horizontal lines. The angle of elevation and angle of depression always have to connect to a horizontal line. This can be tough to understand, but we're going to do a bunch of questions here in a second that will help us out. So, the very first one. If a plane, which is cruising at an altitude of 30,000 feet, was to land, it must begin its descent so that the angle of depression to the airport is 7 degrees. Illustrate this in a diagram. So what we're going to do is we're going to draw some sort of diagram that would show this. We have a plane up in the air. We have an airport down on the ground. That plane needs to land on that airport. So we draw it such as that. Now it says here in the question that it has an angle of depression to the airport of 7 degrees. If we need to put that in here somewhere, what we need to do is we need to draw a horizontal line where the airplane is, and we need to go downwards from that line. And that will show you where your angle of depression must be. Now, another thing in this question that people miss is the word altitude. Altitude of 30,000 feet, that means height. So altitude means height, meaning that this plane is at a height of 30,000 feet. We connect our bottom, and you notice, there we go, there's our right angle triangle. The problem with this triangle that we just built is that it doesn't have an angle inside of it. You notice that the 7 degrees is outside of the triangle. So if we want to figure out what goes inside the triangle right here, we have to use some intuition. And that intuition tells us that if we were to connect this line that goes vertical with this line that goes dotted, we would have a 90-degree angle. Meaning that if the first chunk right here is 7, the remaining chunk that we're looking for would be 90 minus 7. Giving us an angle of 83 degrees inside of the triangle. Now we have a triangle, we know the angle inside, and we have a side length, so what we need to do is just answer our question of how far will the plane actually travel. The plane is traveling along this hypotenuse line, so we're going to call it x, because we're not sure what it is, and that's what we want to find. Your first step to solving this problem is Sohcahtoa. So you obviously need to label your sides. Opposite, adjacent, hypotenuse. You write out Sohcahtoa. And one of them will have 3 crosses. In this case, it is ca, meaning that we need to use the cosine ratio, which is cos equals adjacent over hypotenuse. When the letter that you're looking for is on the bottom, it needs to switch spots with the cosine, so it becomes x equals 30,000 over cos of 83. Punch that in your calculator. Make sure your calculator is in the proper mode if you haven't been getting the same answers as me. So 30,000 divided by cos of 83. and you get that the plane actually travels a distance of 246,165 feet. Guess we should box that. Alright. Question 2 on this page. From the top of a fire tower, a forest ranger sees his partner. So we have a tower, and we have a man on top of this tower. He has a partner somewhere down on the ground that he sees. And it says here in the question that he sees him with an angle of depression of 40 degrees. So that means that we need to draw a horizontal line at the man and then create an angle downwards off of that horizontal. So that tells you right there is 40 degrees. If the tower is 45 feet, so let's label that 45 feet. How far is the partner from the base of the tower? So they're asking for this bottom line down here, so we'll call it x. Again, we have a problem where we've built a nice picture, we have a nice diagram, but we don't know what this inside angle is here. So we need a way to figure that out. Our trick was that we do 90 minus the outside. So 90 minus 40 would be 50 degrees. Again, you're going to answer this question. It's exactly like the question above. You're going to do Sohcahtoa. You're going to do cosine. When you do cosine, you're going to get 45 divided by the cos of 50, and your answer should be 70. So go ahead, try that on your own. See if you get an answer of 70. Sorry, that is not your answer. My mistake. We are actually looking for something different than I thought we were. We are going to have to use the tangent ratio in this question. So my apologies if you wrote that out and you got it wrong and you're like, what am I doing? It's my mistake. We're looking for the opposite side, and we have the adjacent side, meaning that we needed to use tangent. So tan of 50 equals opposite over adjacent. You're going to multiply both sides by 45, so we get 45 times tan of 50. You punch that in your calculator, and that will give you your answer. Making your answer 53.6. I'm sorry, I apologize for that. If you wrote that out, pause the video. Okay, we have a couple more questions to go. So this one, a point is located on a Cartesian plane. So we need to draw a Cartesian plane. The point is at 3, 5. So 1, 2, 3, and then 1, 2, 3, 4, 5. It's up here. Determine the distance to the origin. The origin is the very center, so we're trying to figure out how far this is. How far is that line? When we don't know something, we call it x. Now remember, this is trigonometry, so no matter what, you should have a triangle in every question. So what I'm going to do is I'm going to take this point, and I'm going to create a triangle by going straight down and then straight across. And the good thing about doing that is I actually know those distances, because when we plotted our point 3, 5, I had to go 3 to the right and 5 up to get there. So that actually tells me how far away I am. From 3 to the right, 5 up. Those are my sides of my triangle. If you have 2 sides of a triangle and you want to find the third side, you can use Pythagorean Theorem, where the hypotenuse is C and the other 2 sides can be called A or B. In this case, we have 5 squared plus 3 squared equals c squared. If you punch the 5 squared plus 3 squared in your calculator, you get 34 equals c squared. And your very last step to Pythagorean theorem is always to square root both sides. So the square root of 34 is your answer. That's an exact value. Do not put it as a decimal. So see how it said exact value in the question? Because of that, so that right there was hidden up. That means no decimal answers. All right, down below, solve for x to the nearest tenth of a centimeter. Questions like this, I will call them double triangle questions because there's more than one right triangle. I'm going to highlight one of the right triangles in red. I'm going to highlight the other right triangle in blue. Now, a key to these things is usually if you can figure out what the two triangles have in common, then that's usually a good thing to find first. In this question, we notice that these two things have this line in common. Meaning that if we can figure it out by using one of the triangles, then we can use it on the other triangle. And since we want to find x over here on the blue triangle, we need to know one of our other sides to be able to find x. If we look at our red triangle, we have a side and an angle. If you have a side and an angle, you can use Sohcahtoa to find whatever you want. So our first step is to find this side that they share. I'm going to call it y. I'm not calling it x because they've already used the letter x. So I need to find side y. My first step is label my triangle. So I'm looking for my opposite. I have my adjacent. There's my hypotenuse. You write out Sohcahtoa. You realize you have to use the tangent ratio. So tan of 33 equals opposite over adjacent. You have to multiply, so it's going to be 12 times tan of 33. And you get that y equals 7.793. Now that we know that this side right here, what it is, this side that we share, we know this thing is 7.793. We can use Sohcahtoa on that blue triangle to figure out x. And that was always our goal, was to figure out what x was. So your first step now is to work with the blue triangle and label out Sohcahtoa. Again, we have this is the opposite, but now we're looking for the adjacent. There's your hypotenuse, just in case. You have to use the tangent ratio. So tan of 60 equals opposite, 7.793, divided by your adjacent, which is x. That means we need to switch spots. Like so. If we put that in our calculator, 7.793 divided by tangent of 60, we would get that x equals 3. Just like that. And it says to the nearest tenth of a centimeter, but it would be 2.99, so that would round up to 3.0. So we could drop 0.0 in there if we really want to get technical. All right. 2 more to go. First one, Francois is standing 10 meters from H.J. Cody. As he looks up to the top of the building, the angle of elevation is 39 degrees. Or sorry, 49 degrees. If Francois is 178 meters tall, how tall is the school? So we're going to draw this out. We've got H.J. Cody. There's the building. We've got Francois. Francois is looking up at the top of the school, and he has an angled elevation of 49 degrees. So we have to draw that horizontal line, and we have to put the angle up from the horizontal line, because angle of elevation means to look up. We also know that he was standing 10 meters apart from it. So our bottom is 10. The question now is how far or how tall is the school? So we're looking for this over here, x. Your first step is going to be to label it all out. So H.J. Cody is the opposite. The 10 is the adjacent. Our hypotenuse is the other side. We have to use the tangent ratio. If you did Sohcahtoa, you would know that. Tangent of 49 equals opposite, which is x, divided by adjacent, which is 10. So you need to multiply that over to the other side. The tan of 49 will tell you what your x is. So 10 times tan 49, and you get that the school is 11.504. Notice that I always carry a few extra decimal places until my final answer. You never round until your final answer. Alright, 11.504 isn't our final answer. And the reason why is we measured how tall the school was from his eye level. What we didn't measure was all of this. We have to add on to the fact that Francois is 178 centimeters tall. So 178 centimeters is the same thing as 1.78 meters. You just move the decimal place 2 spots to the right. Or, sorry, 2 spots to the left. The reason we changed it to meters is because they told us that Francois was standing 10 meters apart, so we have to be working in meters. All we have to do is we need to take how tall it was from his eye level and add how tall he was. You punch that in, and you get 11.504 plus 1.78, and you get 13.3 meters. And notice now that is when we round it to the nearest tenth, like the question asked us, because that was our final answer. Alright. Determine the length L to N to the nearest tenth of a meter. So if we look at this triangle, we're looking for length L to N, so from here to here. Unfortunately, that length that we're looking for is not a part of any of our right triangles. So we have 2 right triangles here again. We have this one in blue, and then there's this one in red. And we only know how to work with right angle triangles. We have no idea how to do anything that isn't a right angle triangle. So what we must do is figure out what this entire length is, L all the way to O, and we need to subtract out the little piece that we can find over here from the red triangle. So our very first goal is we have to figure out what this bottom of the red triangle is from N to O. So over here we're going to work on N to O. Your first step is label your triangle. Opposite, adjacent, hypotenuse. You're going to use the tangent ratio. So tan of 63 equals opposite over adjacent. We have to switch spots. If we put that in our calculator, we'll get that N to O is 5.605. So that's from N to O. The next thing that we're going to have to figure out is L to O. Because we're going to want to do this entire side, L to O, and then subtract out N to O, and that will leave us with L to N. So now we need to relabel our entire triangle, but as if we're working with the big blue one. So O is still over here, your opposite is 11, your adjacent is on the bottom, there's your hypotenuse. Again, you're using tangent, but this time it's of 40 degrees, and it's equal to opposite 11 divided by adjacent, which we don't know, so we're going to call it x. They have to switch sides. You put that in your calculator, 11 divided by 10 of 40, you'll get that L all the way to O is 13.109. If you take L to O, so that's the big side all the way across the bottom, and you subtract N to O, you'll be left with L to N. So let's put that in our calculators. We're going to go L to O, so 13.109 minus 5.605 equals L to N. So 13.109 minus 5.605. And you find that L to N is 7.5. We round because that's our very last step. That's why we rounded. All right. Last two questions. The first one says determine the three primary trig ratios. To figure out the three primary trigonomic ratios, you need to know what the three primary trigonomic ratios are. The three primary trigonomic ratios are sine, cos, and tan. And notice that they've used this as our angle. They've labeled it for you. So you should put that in there as well. That means alpha. The sine ratio is equal to opposite over hypotenuse. Cos is adjacent over hypotenuse. And the tangent is opposite divided by adjacent. And they want you to write those three ratios out. So instead of saying opposite over hypotenuse, they want you to actually use the numbers from the triangle. So our opposite is over here. Our adjacent is down here. And our hypotenuse is up here. At this point, we can't figure out what the sine is because we don't know what our opposite is. So we have to solve for the opposite side before we can even write out the trigonomic ratio for sine. So to figure that out, we need to use Pythagorean Theorem. Pythagorean Theorem tells us c squared, which is that, minus a squared, which is 99, equals b squared, which is our opposite. So 101 squared minus 99 squared equals b squared. If you put that first thing in your calculator, so 101 squared minus 99 squared, you're left with 400. equals b squared. And your last step is to square root 400. So that means b equals 20. Our opposite side is 20, meaning our sine ratio is 20 divided by 101. Your cos ratio is adjacent divided by hypotenuse, so it's 99 divided by 101. And your tangent ratio is opposite divided by adjacent, so it's 20 divided by 99. That's your three primary trigonometric ratios. So we've solved the first part of the problem. Now you notice that there's a second part of the problem that says, what is the size of theta to the nearest degree? You can use any of the primary trigonometric ratios you want. I'm going to use sine to solve it. And remember, anytime we're finding an angle, we want to do second sine. So it's sine with a little -1. And the fraction that goes inside the brackets. If you did this with any of the other ratios, so if you tried cos and you tried tangent, it would actually work as well. That means that theta is, to the nearest degree, 11 degrees. Our final question. So, determine the sine of theta from the origin. The origin is the center, so right here, to the point 3, 4. So 1, 2, 3, and 1, 2, 3, 4. To this point out here. We need to draw a triangle. It's pretty hard to do trig if you don't have a triangle. And if you remember from our previous question, to draw our triangle, what we did was we went straight down from our point and then straight across from our point. We know what those side lengths are. Those side lengths are 3 and 4, because that's how we ended up getting to that point. We went 3 to the right and then 4 up. If we want to determine sine of theta equals opposite over hypotenuse. And in our triangle that we've set up, we have opposite, we have adjacent, but we don't have hypotenuse. That means we need to figure out what our hypotenuse is first before we can actually figure out what the sine of theta is. We need to use Pythagorean Theorem. So 3 squared plus 4 squared equals c squared, because c is always the hypotenuse side. If you do 3 squared plus 4 squared, you get 25 squared, 25 equals c squared. Square root both sides, and you get 5 equals c. So 5 is your hypotenuse. So your sine of theta equals 4, which is the opposite, divided by 5, which is the hypotenuse. And that is the end of applying trigonometry. So that's a lot of different styles of questions. Feel free to rewind it and slow it down. You can come to class and ask me questions if you're confused about why anything happened in this lesson. And you're ready to write your unit test for trigonometry. So good luck.